Okay, so hello everyone. Welcome to the AI for Good talk. Today we have the pleasure to receive Sukwoong Choi, who is a postdoctoral associate at MIT. So he's affiliated with the MIT Sloan School of Management, and also affiliated to CSAIL, right? And he's part of an initiative called on the MIT Sloan School initiative on the digital economy. So he's interested in innovation and entrepreneurship, and in particular the economics of AI, how AI affects human decision making. So it's going to be the topic of today. He's interested in human knowledge, corporate R&D, and the labor market. He received his PhD from KAIST in Korea. It's the top, one of the top universities, top business school in Korea. And during his PhD, he visited the Haas Business School, also the top business school on the West Coast at Berkeley. So I think that you'll see that Sukwoong Choi will be talking about Go. So you don't have to be a professional in Go, but everybody has heard of AlphaGo. So I'm sure we'll go over the details. So the floor is yours, Sukwoong.
Yep, thanks a lot for your the great introduction. And hello everyone. My name is Sukwoong Choi. I'm very happy to be here presenting my co-authored work. Let me share my screen. Can you see my screen? Okay, great. So this study, the title is How Does AI Improve Human Decision Making? Evidence from the AI-powered Go program. I will call it the APG, so AI-powered Go program. So this study is in collaboration with Namyo, Junshik, and Hyo. And by the way, I really like that the reason why I accepting this talk is when I checked that the group's title is the artificial intelligence for good. So I like that this title. So yeah, that is the reason. So okay, so except my introduction. I mean, yeah, he gave us the great introduction for me. So I just want to emphasize what I'm working in the MIT. So in MIT. My research project is the economic effect of quantum computing and algorithms. And currently, I'm working with Professor Neil Thompson. Okay, here is a motivation. Actually, I have a personal experience because my English is the second language. So when I wrote that the blue collar workers in the world, so I just wrote that some kind of, okay, there are blue collar workers. So at that time, I didn't realize that it was wrong. But in Gmail, so when I wrote that the same thing, but Gmail is the let me know is like there's a warning sign, so you should change the color. I need add to one more L, right? So I realized that, okay, so I learned from the Google's word suggestions, and actually, as you know, that technology is based on the advanced NLP and AI techniques from Google, and the Gmail dictionary is more knowledgeable than me. So this is one of the kinds of the example how I can learn from AI. So this is one of my personal, the motivation, and I actually believe that you also, you may also have the same experience. I believe so.
Yes, even though as for NLP, for instance, Alexa sometimes doesn't understand my French accent, so sometimes they have problems with a non-native speaker.
Yeah. So yeah, there's a general motivation. So the AI, the availability of AI has broadened because of the accumulation of large data and the advancement of AI algorithms. So from these two characteristics, the AI AI can have higher accuracy than ever. So we can easily observe that very interesting phenomenon. So which is in some domains, AI has already outperformed humans, such as medical diagnosis, drug development, and strategic gameplay. So in our research team, we can come up with these two research questions from this interesting phenomenon. So, does AI improve human decision making? If so, how the effects vary? So, yep, is it correct? That there's two people ask some questions or not? So I can see that the raise hand. So
then let's go ahead. We'll take the questions at the end, okay? If you don't mind.
Okay. In strategy literature, there are two research streams, such as first one is human versus machine. So will AI replace human jobs? That is the substitution law. The other case is human plus machine. So will AI help human jobs? That is complementary law. So in existing literature, they are focused on two streams of that. But however, our focus is human, particularly human trained by a machine. So you can also think about this by the personal experience. So because AI provides the quantified values for decision making, so AI can take a role such as the instructional roles. So AI can train humans. So that is our research focus. Particularly in the literature of human decision making, there are key challenges. First one is it's very hard to observe human decision making, and secondly, it is also difficult to measure the quality of the decisions. And in our research question is relevant to the usage of AI. So in the literature of the human decision making, there is a lack of literature to examine the usage of AI. So to overcome these three key challenges, so we found the appropriate context, research context, namely professional Go game. So in Go games, we can easily observe human decision making because every single moves by Go players are their decisions. And as you know, since the historical match between AlphaGo and human Go master, so the game Go is one of the initial area to use AI. So since the historical match, there are several AI-powered Go program. I call it the APG. So using the APGs, we can measure that the decision quality, error, and mistake. So here are a preview of our findings. So we analyzed 750,000 moves in 25,000 games by 1,200 players. So our main finding is APGs significantly improved the move quality of players about 31%. And as the mechanisms, we found that there are some reduction of the number of errors and the magnitude of the most critical mistake. So we also considered some heterogeneous effects. So depending on age, so we found that the younger players are more prominent than the older players. And depending on the exposure of AI, the China and Korean players are more prominent than Japanese players. And lastly, we also found that the early stage of the game is more beneficial. Okay, let's jump into my paper in detail. So I want to explain the game Go briefly, because some of you are aware of this game. For the others, let me explain it briefly. So Go is a two-player strategy board game, and it was originated from China 3,000 years ago. So to play Go, we need a Go board. This one, so 19 by 19 Go board, and we need a black and white piece, but we call it the stones. And the way to play is two players move alternatively. Two players place alternatively. And the purpose of this game to gain more territory. So the way is, there are two ways to get more territories. So if you can make some better front, or you can also capture the opponent stuns. I also prepared one video clip relevant the how to play Go and how to link Go and AI.
Go is the world's oldest continuously played board game. And in some sense, it is one of the simplest and also most abstract.
There's only one type of piece, there's only one type of move, you just place that piece on the board. And then your goal is to create a linked group of your stones that surrounds some empty territory. And surround enemy stones, you capture them and remove them from the board. You earn points by surrounding territory, and at the end of the game, the person with the most territory wins. It seems really simple, but then you sit down to play and you realize right away, it's like, well, I technically know what I'm allowed to do, but I have no clue what I should do.
Go is incredibly challenging for computers to tackle because compared to, say, chess, the number of possible moves in a position is much larger. In chess, it's about 20. In Go, it's about 200. And the number of possible configurations of the board is more than the number of atoms in the universe. So even if you took all the computers in the world and ran them for a million years, that wouldn't be enough compute power to calculate all the possible variations. If you ask a great Go player why they played a particular move, sometimes they'll just tell you it felt right. So we have to come up with some kind of clever algorithm to mimic what people do with their intuition.
Yep.
Very good. Yeah, this is, I think, for everyone. You can watch this movie on YouTube. I think it's available. I think that's a whole movie, right, from DeepMind.
Yes. Yeah. It was. It was brilliant. So yeah, and I want to mention that the similarity playing Go to managerial decision making. So there are the three characteristics. The first one is when you play Go, we need to analyze the environment and also make judgment and decisions, and also the reflect on the the result. And as I mentioned, that the Go is the two-player games, so there are always the competitors. So it's quite similar to in the business world. So we should consider the perspective of competitors. So lastly, Demis Hassabis also mentioned that the playing Go is quite similar to use the I should use the the human intuitions. So it is also, so when we have a managerial decision making, so we need to have an intuition under uncertainty and time constraints. So it's quite also similar similar characteristics between playing Go and managerial decision making. So based on these characteristics, there are also some, the articles, from the University of Virginia. So competitive dynamics and the game of Go. And the other case, because the playing Go is to gain more territories, and it's quite similar to the market entry. So actually, as you see that this photo is represent the competition between iOS, the Android world, I think, and it would be quite similar way to think. Yeah. And in the clip is like the Hasabe also mentioned there's some clever algorithms that is the AlphaGo. So, but we are not sure how much better are APGs compared to humans. So here is the figure. So y-axis is the error rating, represent relative performance, and the x-axis is the year. So over year, the error rating is the going up. Actually, the best error rating, the best human players error rating score is about 4,000. However, the recent version of the AlphaGo is over 5,000. So the gap between them is over 1,000 points. So which means that it is almost impossible to win against the APGs. However, it is very appropriate context to examine our research question.
Sukwoong, is AlphaGo commercially available, or how do people play or train with AlphaGo?
It's really great question, and then I'm gonna mention that after this slide. So okay, yeah. So yeah, maybe the next slide. Yeah, okay. And and we also okay, so APG is the better than human players, and how APGs we need to, we want to know that how APG fundamentally changed Go training. So before the release of APGs, when we learn Go, so we use tutoring, self-learning, and group discussions. However, these ways, we don't know that which move is better exactly. Which means that using this method, they just they just think this move is the better. Which means that they just depends on their heuristics and the experience. However, after release of APGs, here are the real games. So actually, that is the battle professional Go games from the Jisoo Kim and then Sedo Lee. So as you see that this figure, the game is up to 98 moves. So the timing is to the 99th move, the black stones. So as you see that when I select this blue colored position, we will get that the winning probability about 65.5%. However, when you select this yellow one, you will get that the 65 winning probabilities. So the APGs provide these quantified value, which move is the best. In this case, to increase their winning probability. So Go players can be trained using APGs. So which move is better? Yeah.
And will the APG explain? Oh no, there's no the APG doesn't. Can you drill to understand why the APG is saying this 65%? And otherwise, it's a bit of a black box. Otherwise, right?
Yes, yeah. Actually, the AlphaGo is still a black box, and then that is the reason we just discussed about the explainable, the AI, those of things. But the AlphaGo is not. APGs is not couldn't provide the reasons. But when I look at when I actually interview the Go professional players, but they just try to find the way why APG's this move is the best among the candidates, these candidates. So it's like the backward or the driven way to guess, but currently that is the best way. But when their rank is really higher, but they can get what I think I realize that they are more easily to find a way. So that is the interesting phenomenon I could found. And yeah, that is the answer. So actually the AI AlphaGo is just algorithms, not a program. So it is at that time, March 2016. It is impossible to use Go players directly use the program. However, after 1 year, the Lina is released as the first freely available to the public. So using this APG, using this release event, we can compare the before and after Go players move quality. So here are our data. So we collect, the professional Go games from 2015 through 2019. And our unit of analysis is player game level. And our method is we used model-free analysis and event study and differences model. So using APG, we can calculate the winning probability for all moves. So our dependent variable is move quality, so which means that the average difference in winning probability of the poker player's move compared to APG's corresponding solution. So if the Go poker player's move is exactly similar to APG, so their move quality is the best. So that value should be the 0. So 0 means the highest quality. And if the move quality is represents the negative value, so which means that the player's move quality is lag behind the AI's move quality. So, and our studies, at the beginning, our study is focusing on the opening strategy, because opening strategy is the most important playing Go. Our independent variable is post. Is the dummy variable, so to represent the after the release of the Lila event. And you also consider the variable young. So we use the median age of median age for to represent that group. In that case, the younger than 28 years old. And you also consider several control variables: rank difference, which players is white, and the 7.5 common is one of the compensation. Compensation to play Go.
In your database of games, do you have games from computers? Did you record games of computers playing against players, humans?
What does that?
In your database of moves, right? Do people record the play? Do you have games between computers, like Go computers, or between computer and a human?
That is really great question, and then I need to clarify that part. As I mentioned, that this study is not for the complementary issues. The Go player plus the AI machine. So actually, in this data, the professional Go players games. So there are in in professional world, in a Go, there is a battle among players trained by AI. So they couldn't use AI program directly when they play the game. So there are just game, among the human players. But everyone, I mean, as you can see that later, but currently every professional Go players use APGs, and then they are trained by the APGs. So yeah.
But they're not allowed to use APG in a game, right? I think the paper says that.
Absolutely, yes. So here are our results. So I think this figure is the most important figure in our study. So here is our model-free evidence. So y-axis is the average move quality of players, and x-axis the time. So as you see that the red dashed line represents the release event. So before the release event, the trend of move quality is quite similar. However, after the release of APG, the average move quality of players has drastically increased. So when we test it, when we are using the regression models, when we test it, the effect size is about 30%. So 30% is quite a large number, right? And you also examining the age effect. So our model-free evidence showed that before the release of APGs, the younger players and older players, their move quality are quite similar. However, after the release of APGs, younger players' move quality is more prominent than older players' move quality. So when we tested, we found that the effect size is about from 9 to 11%. Younger players move quality is more prominent.
Do you have like older players who don't use APGs? So they're too old, they don't know, they don't practice, they don't believe in APGs and so on. They just keep playing the way they used to play.
Actually, when based on our interview, they are also trying to use the APGs, but we can guess that that would be the openness to new technology. So I think it would be possible, but at the beginning they're not. It is true that they didn't believe APG, but however, after over time, because the APG has superhuman capabilities, so they should admit that. So yeah, but yeah, unfortunately, but we have no data to trace how they are actually use the APGs. So our study is maybe. That is some kind of the proxy. So
that's why you have to do that kind of event study.
Yeah, event study, and in this case, different estimation. And we also conduct several robustness checks, but I'm gonna skip that part. And also interestingly, we want to find that we just say that the country effect, but it would be the first mover strategy. That results. So So what I want to say is like, so there are two events about the AlphaGo. So the China and South Korea. So China and South Korea are more exposed to APG compared to Japan. So actually, these three countries are major, major countries to play Go. So when we, using the Google trend, when you find that when we find the internet search volume between them, so the Google trend showed that the China is 100 and Korea is 92, but Japan is just 5. So we can confirm this. Okay, there are some the huge the differences of the awareness of the AI.
So they are the non-believers then, right? You could say the Japanese are the ones who don't believe in APG, maybe.
I'm not sure it's like that is just, for the belief. So which I want to say that is like, that is the AI exposure at the country level. Because, I was in there, in the battle, in the AlphaGo versus the Sedorly, the first event. But, almost Korean, watch it, the matched game. So because, we are really, we are actually at that time, we really focused on, that event. I mean, the China is also too, the AlphaGo versus, Kaze. So, the Kaze, another, the Go player from China. So our model-free evidence, our results show that it's like, the red and the red line is China and blue line is Korea and the gold line is the Japan. So as you see that before the APGs, their move quality is quite similar. However, after the release of APGs, the Korea and Korea players and Chinese players, their move quality is quite similar. However, the Japanese players' move quality is lag behind. Then the China and South Korea, the players are from them. So, and when we tested, when we empirically tested, and we found that the effect is more prominent for Chinese and Korean players. And the effect size is from 9 to 13%.
So there's a rank. You have a rank effect, right? So it means like the stronger the player, the bigger the effect of playing with APG. Is that how you read it, or?
Based on in this table, that there are the positively correlated, yes, rank.
Probably if you are like a weak player, like following the AI doesn't really help you. It doesn't because you don't understand what's going on. So probably you don't learn much. But if you are very advanced, probably you can benefit more, maybe.
Yes, but just only we consider just rank effect. Yeah. Honestly, we couldn't find the linear trend actually.
Okay.
Yeah, so I mean it is quite inconclusive, but I also still believe that there would be something, but I couldn't find that empirically just when you consider only rank rank effect, but yeah. And also that rank is not our research focus too, so that is not our research focus, so yeah. And we also we can easily come up with just one idea, like some, as the mechanisms, where does the improvements come from? So we measure that, the error. So error means a move that the 10%, more than 10%, the number of more than 10% drop in winning probability. And the critical mistake, we just measure that the critical mistake is the magnitude of the biggest drop in winning probability. So our model-free evidence show that both of them, their trend has decreased. So we can realize that we can know that that there are some improvements going up. However, that reason to the Go players errors, the number of errors has decreased, and the critical mistake is also decreased. So lastly, we can also think about that. We can also easily come up with these improved lead to winning games. So using the Baron and Kenny, the three-step mediation analysis, they can say that the younger players are more likely to win about 6% than older players through this improvement. Lastly, we also consider how does the effect vary throughout the game. So when we consider, when we include the later stage of the games, as you see that the first column is up to 30 moves, but last column is up to 180 moves. So in this case, the beta is the value of the beta has decreased over including the later stage. And lastly, the significant was gone. So we can see that the improvement is greater in the early stage of the game because of in the early stage, there are lots of the uncertainty. So we just interpret that it's like some, the effect of AI is more prominent when we have more uncertainty. So here are 3 key takeaways. So the first one is when AI is better than humans, it makes humans better. Quite optimistic view, right? And secondly, not everyone may enjoy the benefits of AI at the same level. Our empirical findings show that it would be depending on the age and the exposure of AI. Lastly, we also confirm that the impact of AI also depends on the uncertainty of a situation. So here are our research, the contribution to the literature, but I'm gonna skip that part. And yeah, so I also prepared.
So that literature, what does it say? Does it agree with you that people like humans trained by machine get better? Is it? Do they agree with your findings?
Actually, our study is we believe that our study is the first study, examining the training role, the instructor role of AI. So we just say that, so we just provide new empirical evidence about how AI transforms human decision making, particularly human trained by a machine. So that is the first contribution.
That paper, I guess it's Eric Bijobson, Wang, and Zhang. What do they say in that paper?
Actually, their paper is about the corporate paper. We need those of the studies. So we just say that our study answered to them. So yeah, that is the reason why I mentioned that. So, and then actually I'm from the business school. So, I also, add the human capital, the literature in the context of the AI, and you're also examining the boundary conditions of the use of the AI.
He's a professor at MIT, right? That Jobson, right?
He was actually he moved to
he left Stanford. Yeah, he moved to Stanford, right? That's cool.
And yeah, here are there is a message from the Weibo message from Choi. So Choi is the second in the article ranking professional player. So he just said that he just said that the humans have evolved through thousands of years of actual combat exercises, but the AI powered Go program has told us that humans are all wrong. Go players will combine computers to enter a whole new field and reach a whole new level. So this is how the Go players are thinking about the APG. So they are really focused on, we can see that they are really focusing on the APGs open the new world, the new level, I think. So using these concluding remarks, we also examining in our future study, we also examining could AI generate new knowledge. So in this case, the new opening strategy. So we found that our primarily the results showed that after the release of APGs, that there are huge different AI can suggest the new opening strategy, and then the professional players really follow their APGs opening strategies. And the other case, our team is also expanding to different contexts, but the same logic is like particularly the university hospitals. So when we interviews the younger and older the radiologists, they are really get some help from the AI-based triage program. I forgot the the real name, but the AI the AI powered the medical device. So our team is try to examine these context too, and then the stages under the IRB. So yeah, please keep your attention. Yep. Thank you for your attention.